Natural disasters are on the rise. Whether it's hurricanes, flood, earthquake, all of them are affecting the ability for data centers to remain online. Yet, there are many data centers who are not ready for disaster events. In fact, a 2018 study by Uptime Institute shows that more than 70% of the data centers are unprepared for disaster events. Yet, when your data center goes offline, it is not only lost revenues, but also it impacts your business reputation, customer loyalty, and so on. Now, with the advent of cloud, making the disaster recovery happen there, making it much more affordable, because now you don't need to have a secondary data center. There are additional benefits as well. So for example, you can take advantage of the geodiversity that public cloud providers like AWS provides. The software for disaster recovery is also getting very advanced. Now, electronic versions of integrated runbooks are very sophisticated with complex ordering, checkpoint, custom scripting, network modification, so on and so forth. But then, these cloud-based disaster recovery solutions have their own set of challenges as well. The first and foremost is, in a lot of situations, it undergoes a transformation or translation. So, for example, if the disaster recovery to cloud software takes advantage of vImport feature of AWS, that means the VMware VMs is getting translated into native AWS AMI format, and if it is happening when you are in the middle of disaster recovery, then you know what, you might have a disaster while having disaster recovery. And then the new processes or technology also plays a role in terms of how effective and how quickly you can bring up your environment to the cloud. So let's take a scenario where you can actually have your on-premises data center recovered into the cloud, leveraging your the same set of operations with a consistently familiar environment to get there. So you know of VMware Cloud on AWS, it helps you extend, migrate, and protect your on-premises vSphere-based environment to the cloud. And you can actually take advantage of the native AWS services as well. Now, here are two issues. First is the storage in VMware Cloud on AWS is actually tied to the compute nodes because it's primarily vSAN based. And the other part is this is non-persistent, meaning when you take a node out, the storage associated with it goes away. So it is not only complex but also non-persistent. Now we are going to talk about a solution where VMware and VMware Cloud on AWS provides a feature called external storage via managed services provider. What it does is it lets you have storage directly connected to VMware Cloud on AWS from a managed service provider, and this AWS Direct Connect is actually managed by the service provider with patented layer 2 technology, and the access to this external storage is less than 3 milliseconds. So let me build this out. So you have your on-premises data center, you have your VMware Cloud on AWS, which through which now with the cloud control volumes, this is the NFS data stores that we are exporting out from the managed services provider directly attached to the VMware Cloud on AWS. Now you are getting enterprise grade storage access as like on an on-demand basis. And in fact, this is persistent, durable storage managed by the cloud services provider, guaranteeing you, give or take, less than 3 milliseconds of latency. Now, how you can leverage this to build out your disaster recovery solution? So, you can actually have a pipe or connection from your on-premise site to this managed services cloud. You replicate from your on-premises Dell EMC storage, like Dell EMC Unity, to the Dell EMC Unity that's on the managed services provider side. Okay, native replication gives you your data and VMs are replicated to the secondary site, which is this managed services cloud, and then the cloud services here can help you get those cloud control volumes mapped to VMware Cloud on AWS in the case of a disaster. And that, like, this becomes like your automated DR operations, where the entire environment from on-premises to, in the event of a disaster, are getting up and running on VMware Cloud on AWS. And here you are actually like not needing any additional storage. You are consuming compute in the case of the disaster on an on-demand basis. It is lowering your both RPOs and RTOs, bringing up your environment. And this is actually first and only storage for VMware Cloud on AWS services leveraged for the disaster recovery. Here is another version of it. Here you are leveraging VMware Site Recovery Services in VMware Cloud on AWS to have your both data and VMs replicated to the VMC on AWS. And in the event of the disaster, you can actually have your data center up and running, leveraging say Dell EMC Unity or Dell EMC PowerMax as the external storage on which you are running your workloads in a consistent manner. Like your same vCenter and everything else is going to work again. This is the first and only solution where you can leverage purpose-built storage for your DR applications running from VMware Cloud on AWS. Let's do a demo. So what you are seeing is, this is the Dell EMC Unity interface. It's operating in your on-premises data center. You can see it is up and running. You can see the IOPS average, bandwidth average, so on and so forth. Now let's see what's being replicated. You see the bottom three data stores marked as file systems. So this is your on-premises data store. And then the top three shows up as NAS server. This is the replication partner, and this is in the cloud. Now, suppose I want to fail over one of the data stores from on-premise to the cloud. The replication is asynchronous, so it is ensuring all the data that is on-premises now actually like moved over as I'm doing this failover. I'm going to failover this data store into the data store that's here on the cloud. So let me ask it to failover. It's going to ask me whether I am sure. Yes, please. Now, looking at the Dell EMC Unity user interface, I can see this on-premises data store has now failed over to the data store on the cloud. Let's take a look at the vSphere. Now, this is the data center running on VMware Cloud on AWS. If I take a look at the data stores, this data store 3 is where the files are, and let me go there. Now, these are the VMDKs that are on that NFS data store. if I come back here, now let's take a look. This is where in the cloud, all the VMs are going to get moved over and powered up. Look, the CPU usage, memory usage, the DRaaS load balancer is perfectly balanced at this point. Okay. Now, if I take a look at the compute resource pool here, you will see here are the VMs that are getting registered and reconfigured in VMware Cloud on AWS. And these are still not powered up. As it moves through, you will see the green dots coming in, and keep an eye on where the CPU usage, memory, and the load balancer goes. So you will see as the VMs are coming along in green, the CPU and memory usage is going up. The DRaaS load balancer, it's trying hard, but now it has a lot of new VMs in the same cluster. So it is balancing as much as it could. And with these green VMs, you can see that all of these VMs which were running on-premise are now up and running in VMware Cloud on AWS with just a few clicks. So to conclude, this is Dell EMC Cloud Storage Services for automated disaster recovery for VMware Cloud on AWS. This is a new service, and you can come to our booth to learn more. We have lots of more demos, and then we have assessments in place that will help you understand what type of workloads you can actually migrate to the cloud, to Dell Tech Cloud, and can take advantage of this Dell EMC storage cloud services. Thank you.